Hello all, and thank you for listening to one more video of Mr. Laxton talking through these Algebra 2, and this one is specifically on completing the square. So section 5.5 today, this is the second to last method that we're going to learn to solve quadratics. So we've learned how to solve quadratics by factoring, so we set those factors equal to 0. And find those answers. We also learned how to solve quadratics by taking square roots. So that's when you just isolate that squared term and take square roots. And now we're going to learn completing the square, and then the next section will be on the quadratic formula. All right, awesome, awesome, awesome. So here we go, factoring. This first one here, this one's just kind of a getting us in here. So factor the following. So we know that, hey, factor this, we got to put this guy in the diamond. It's got 3 terms. So 16 goes on the top, 8 goes on the bottom. So I notice here, I look at what 2 things multiply to 16 and add to 8. And if I look at that, I know that, hey, 4 and 4 multiply to 16 and add to 8. So this is going to be x plus 4 and x plus 4. All right, and this is kind of a special deal because we know if we ever multiply something by itself twice, we can just call that itself squared. So we have x plus 4 squared. So this is what we call a perfect square trinomial. And this is going to be what we're trying to make today, because this is going to help us solve some of these quadratics that really aren't factorable. Okay, so we can't put something on the top and the bottom. So if I just look, I'm going to scroll down, I'll come back up, is that if I look at this first example here, if I try to put 10 on the top and 8 on the bottom, if I try to find 2 things that multiply to 10 and add to 8, I can't. All right, so the only things that multiply to 10 are 1 and 10, and those add to be 11, and then 2 and 5, which adds to be 7. So there's no two numbers. That multiply to 10 and add to 8. So we're going to solve this one by using the completing the square instead. Okay, so completing the square is a process that allows you to write an expression as a perfect square trinomial. Square trinomial. Then simplify it by rewriting as a square of a binomial. All right, and we're going to look at what all these words mean here in a little bit. Okay, but the key thing here is, grab out your highlighter, is that to complete the square of x squared equals bx, you have to add this term b over 2 squared. Maybe put that in the box, because that's what we're going to kind of put in the box here today. All right, so that b over 2 squared is that little tiny snippet of an equation that you're going to have to remember. You're going to have to know. All right, so examples. Add the term that completes the square. So in this box goes the b over 2 squared. All right, so I look at my b over 2 squared. In this specific example, my b is 6 over 2, and I have to square it. So my b is 6 over 2. 6 over 2 is 3. 3 squared is 9. So to complete the square here, I have to add 9 in that box. So now if I look here, if I have 2 numbers that multiply to 9 and add to 6, I can say, hey, that's 3 and 3. So whenever you complete the square, these 2 numbers are going to be exactly the same. So this is going to be x plus 3 squared. All right, I'm going to scratch out this next example, and we're going to move on here. All right, so here we go. You can use completing the square to solve quadratic equations. Note the coefficient of the x term must be 1 before completing the square. So here it says my steps here are all these nice steps, and that's going to help us out. First, we're going to isolate the x squared and the x term. So we're really going to get the c term to the other side. So get c to other side. All right. We're going to divide all terms by the coefficient of the x squared term. So if it's not 1, we're going to divide that guy. Then we're going to add that term that completes the square. We're going to add that b over 2 squared to each side. Whoa, what just happened? Where did you go? And we will find it here. There we go. So this is my b over 2 squared. Okay, and then we're going to rewrite that left side as the square of a binomial, and then we're going to take the square root of both sides, and you should always have two solutions here. All right, solution. Whoa, that does not. Oh yeah, that's an n. Does that look like an n? We'll call it an n. All right, awesome. So here we go. Let's look at examples of these, and then they'll make a little bit more sense here. I know they will. Okay, so example number one. My step number one is I need to isolate the x squared. I need to get the c term to the other side. So I'm going to subtract 10 here first. Subtract 10. So now I have x squared plus 8x, and here's where it's kind of the part that's new. I'm going to put a plus box and then negative 10, and then don't forget, if you add this box to the left side, you have to add it to the right side. So don't forget to add the box to both sides. All right, so now you have to ask yourself what goes in that box. It's b over 2 squared. So my b is 8 over 2 and then squared. So I know that 8 over 2 is 4. 4 squared is 16, not 12. So 16 is what goes in those boxes. All right, awesome. So here we go. Now I can look at, since that, so now, hey, I got that with number 2, I divided. So there was no, my a term was 1, so I didn't have to divide by each side. So sometimes you can skip this if your a term is 1. Now 3, we added that term that completes the square to both sides. So I added 16 to both sides. This is a 16 there. All right, so now we have to factor this side over here. So now I have x squared plus 8x plus 16. If you want to, you can still put this in the diamond, 16 and 8. So I know that two things that multiply to 16 add to 8 are 4 and 4. Okay, they're always going to be the same. If you can skip this diamond part, that's awesome. That's great. So now this turns into x plus 4 squared is equal to negative 10 plus 16 is 6. All right, awesome. So now I look at it here, the way that I can solve this, just the way that we've been solving it before, is I'm going to take the square roots of both sides. So now I get x plus 4, because this square root cancels out with that square, is equal to plus or minus the square root of 6. All right, and my last little step, remember you got to subtract that 4 over here, so x equals, remember that negative 4 goes out in front, so it's going to be negative 4 plus or minus the square root of 6. Whoa. There we go. All right, negative 4 plus or minus the square root of 6. So notice, hey, that's not going to be a very nice number. The square root of 6 is not a very nice number, so you're going to end up with some decimals there. All right, so number 2 is a little bit different because it's got this a value that is not 1. So we're going to end up having to divide by that guy. All right, I still like to add the 4 over in the first step, add the 4 over. So now I have 2x squared plus 12x is equal to 4. So that's my first step. So we're done with the first step. So now my step number 2 is to divide each of these by the coefficient in front of the x squared. So now I divide by 2, divide by 2, divide by 2. So make sure you do this at this point. A lot of people take my b is 12 right now and do 12 divided by 2, which is 6, and square that. You have to make sure you divide it by 2 first. So now I have x squared plus 6x plus box is equal to 2 plus box. All right, and what goes in that box? We have my b over 2 and squared. So my b right now is 6. So 6 over 2 squared is what? 3 squared, which is 9. All right, awesome. So 9 goes in those boxes. So now we look here. I added that term that completes the side. Now I have to rewrite the left side as a binomial squared. So I need to factor this guy. Put 9 on the top, 6 on the bottom. You notice here that, hey, these are always going to be the same numbers, so we get 3 and 3. 3 times 3 gives me 9. 3 plus 3 gives me 6. So now this is x plus 3 squared is equal to 11. All right, and now here we just go through and solve this guy, take the square root, so I get x plus 3 is equal to plus or minus the square root of 11. And I subtract that 3 over, subtract the 3, so I get x equals negative 3 plus or minus the square root of 11. All right, Awesome. So I know that's kind of a longer process. I know it's got a lot of stuff, but we're going to practice that a lot. We're going to get really, really good at it. Completing the square. It's going to come out very important. It's going to come up again in like chapter 10. We're going to do completing the square a bunch of times again. So that's going to be something we got to get ingrained into our brain. All right, and the last little guy here, this last little section is we have to rewrite these quadratics in vertex form so we're able to graph them. So we've already looked at graphing in vertex form. So really all here is we just have to complete the square by adding this box on both sides. So we have this b over 2 squared goes into both these boxes here. So now this is y plus b over 2 squared is equal to this guy right here. It's actually going to be x plus b over 2, but you really don't have to remember all this, plus c. Okay, and then now you get the y all by itself. Okay, so I know I kind of talked through that really quick, but here I just kind of want to look at an example here. Is that we got to write this in vertex form. So if you remember graphing in vertex form, it looks like this: y equals a x minus h squared plus k. All right, so we want to try to find, hey, what this h and this k are, so we're able to graph it. All right, able to graph this parabola. But first, we got to get it into that form. So notice this is in kind of the standard form. We want to get it into vertex form. So now here I have y plus box is equal to x squared plus 10x plus box, and then plus 17. Okay, so I like to put that box before the 17 because that's what we're going to use to complete the square. So now in that box is my b over 2 squared, and I know that my b right now is 10, divided by 2 is 5, squared is 25. So 25 goes into both those boxes. So now I have y plus 25 is equal to, and then now I can factor this right here. Okay, so as I factor that, 25 goes on the top, 10 goes on the bottom. So two things that multiply to 25 but add to 10 are 5 and 5. So now this turns into x plus 5 squared, and then plus 17. And my last little step, I just got to get y all by itself. So I subtract 25, subtract 25. So now I get y is equal to x plus 5 squared. And then 17 minus 25 is negative 8. So notice here, hey, this is in standard form. My h is negative 5 because it switches, and my k is negative 8. All right, so that's just kind of a real example of why you would want to complete the square as well, is you want to get it into that vertex form so you can graph these things. All right, so again, like I said before, I know this is kind of a longer process. It's got a lot of stuff going on it, but once we do a bunch of these, it's going to make some sense, I promise. So thanks again for listening, and we'll see y'all later.